Hello there. I have made some changes. Oh wait, we need VirtualBox. So last time I was struggling to import Zydus, and I think I know what happened there. What happened was that when I used the imports, when I included the headers essentially, I included them by default. They were imports via DLL, and of course we are statically linking, so it's not a DLL. And yeah, then it couldn't find the __imp__ thing, which didn't exist because, well, again, it's not a DLL. What I did though was port the whole thing over to CMake because I actually I wanted to do that for a long time now because I prefer CMake, and I didn't do it in the first place because CMake doesn't support making kernel drivers, but I found a separate package which is called find wdk. No, whatever. I found a separate plugin thing so I can use CMake with kernel drivers, and then I essentially built the whole CMake toolchain thing so I can build it with Zydus, and yeah, I got it to work. I didn't want to film the whole CMake thing because it was just pretty boring, pretty standard build configuration thing, not really programming. Yes. So here we are. We have Zydus on the right hand side. Is the hook function. I also changed the code editor because I don't like Visual Studio for building, but I also don't like it for editing. So I switched to VS Code. Alright. Oh wait, music. I always forget about music. What kind of music do I want? Ambient Fortnite music. Yeah, that's a great idea. Do we have the kind of vaporwave Borderlands 3 music? Should be in here somewhere. Athena's Mouthpiece, Skywell. I think that's the one. Let's see. Yes, that's what I was looking for. Yes, let's go. Okay, first of all, we decode. I just want to decode a single instruction and see if the instruction length is correct. So I'm gonna unwhile this, and now it only gets executed once. And oh yeah, we don't need the success either. Oh. Wait. Of course there's a condition, and this shouldn't be tabbed in. here we go. Now we just have to print the offset or the instruction. Just gonna print the instruction length. Log debug instruction len is equal to what's that? LX? Is it? Not sure. Length. Did I just see U8? Ah. Oh yeah, of course. See, printf byte. I'm gonna be honest, I don't know how to print bytes with the format string $HHX. What? So you want to print 1 byte, okay. In that case, you have a char variable, okay. What? Well, I guess this is only for testing, so what else? Let's try. So what I'm trying to accomplish is figuring out if the instruction length it's using is only the instruction or instruction with the opcodes. And WinDBG, we do AD/NT default mask 15, and then we go. Let me just put WinDBG over here so I can see it, and then we can run cmake and build the thing. And it was successful, and now I made a little task to start the driver. Oh, wait, actually... Oh, we can't start it anyways because I didn't launch it as admin. Which of course we need to be to start a driver. Okay. Wait, what happened to the VM? Oh shit, I think it died. God damn it. I didn't even start the driver yet, and it just crashed. VirtualBox seems to be very unstable. At least, to me, on the system. I don't know if it's WinDBG or what's going on, but it crashes way too often. It's very weird. Never have that happen with my other VM. Maybe the OS has just become very unstable with all the shit I've been doing to it. I don't know. But it doesn't happen like all the time, so it's okay. Again, executing, setting the KD default mask. VS Code as an admin this time. And of course I'm gonna start the debugger as well. Debugger is started, and we are going to start the driver. It is on. Actually, I'm gonna stop it before anything bad happens. So, allocated instruction length 5. That's correct. That's exactly what I need. So, access violation, whatever. Is that the entry point? Where the fuck is the entry point? Follow. Here we go. Oh yeah, I think I'm already overwriting it, which is why it's giving me an access violation. We are writing the step to 65, which is 5 bits off, so I'm assuming we are actually taking the offset into account, which is wrong. But we know now that the instruction length is exactly what I wanted. So we do while Zion success this. Oh, wait, what am I doing? This goes in here, and then we do this, and we do that, and this, and we also need to say and offset less than 5. I was thinking about if I should hard-code it or not, but I don't have to, because don't we have a step size? Yes, we do, and this should be 5. Yes, 5. Okay, so we do this until we have reached an offset of 5, and target, function, and offset. Wait, what do you mean, offset? Oh yes, of course. Copy the original to the destination, and instead of the handler, copy into the target from func offset bytes. Now the question is, of course the target is the shellcode memory and the func is entry point. But what I'm wondering is virtual protect memory page read write. And what are we setting? We are setting entry point. Okay. Shellcode memory. We allocate the memory and we set it to read write. So yes, this should work without an access violation. And then next up we set it to the old protection again and set the shellcode to execute read. Yeah, that should be correct. Overwrite original code. Let's just uncomment this one, because we are getting an access violation somewhere. I don't know where. And come on, it's compiled. Really? Are you joking? So this one is probably our fault. I should restrict it to Notepad again, so it doesn't crash every 5 seconds, because that's rather annoying. Yes?
I found parallel universe news.
Alright, I'm back. So I want to try to restrict it to the Notepad, but that's super annoying. Or is it? Hold on. Can I... Why did I not think of that? Since it's not showing the full path, but only the name, I can simply do if... Oh shit, how does string compare work? I know it returns like 3 different options, and I don't know which one is which. Here we go. 0 if the contents are equal. So 0 if the contents are equal. 0 is obviously false. So it needs to be false. So if it's true, we return. I hate how confusing that is. Proc name notepad.exe return. It's that easy. Actually return status. There we go. Build. Oh. Unexpected token. Excuse me. What does that even mean? Okay then. I'm not even getting any more output. This is so weird. Okay then. Does that mean... is that... This is confusing. What? I think CMake build itself just... I don't know, died? In JSON. Yeah, how about just reinstalling it? I have a suspicion we're actually starting to corrupt files on the system with the constant crashing. Which wouldn't be bad, but also kind of funny. Nope. It's not because of the code, is it? It would be a very weird error message for an error in the code. Yeah, it doesn't. That's what I thought. What if it's bothered by this being... by this having Windows line endings? Fuck. It isn't. I'm not sure to delete this. It is complaining about some JSON, I think. this. Yeah, that actually is the extension. That is so weird. Well, that fixed it. I just switched to the preview version. Probably fixed it by accident, if I'm honest. Stop driver, because we actually don't need it yet. I need to first open this, and now we can start it. And we run it. Okay. As we can see, located and wrote it to main. It actually didn't write it. Oh. Oh, now I understand the access violation we were getting. I don't know why, but it doesn't stop at the entry point anymore. Events. Entry breakpoint. It's still on, but it doesn't do it. Ah, that's annoying. Yeah, I'm just gonna manually go there. Set a breakpoint, start, and we're here. Cool. So, next step is actually writing the detour, the stub. I'm gonna open hook.h in here, so we see the defines the header, which is the stub mostly. Copy original code. Yes, yes. Overwrite original code, that's what we need. And I am thinking about using the Zydus compiler or encoder. Zydus. So that I don't have to manually write the bits and the bytes, which then make up the instructions. Request. I set the machine mode. Oh god, are you serious? Oh, that is... I'm gonna need all this for a single instruction. So yeah, I'm just not going to do that. Fuck that. Or wait, reconsidering. No. Done reconsidering. So. Oh, not DBJ, it's E9 upcode for a negative jump. That's a funny way to call it. Yes, E9 is a jump relative 32, that's exactly what I want. Jump shellcode. We say function static cast relative to target. I think we need to switcheroo the arguments. Oops, I didn't want to do a clean rebuild. And why the fuck not? No. It died again. This is definitely not sustainable. I don't know what this means. Some app is having a bad time. Interesting. I do think I might be causing the app to crash though. Let's see. Oh. Oh, I see. Oh well. Okay. So from now on, fuck looking at log output, because who needs that? Yeah, this should not happen anymore. Okay. Are we inside the shellcode? Oh yeah, this does not show jumps. Oh, come on. Symbols, notepad. Hey, wait. There we go, notepad. Entry point. What? What do you mean? Can I? Oh, I thought that's what I did earlier, but evidently it was not. So yes, we got this jump, and this is going to jump to our shallow code, not precisely. Yeah, this is the original bytes that we saved. But why is it jumping here? What? Let's see why that is. So we get the target where it should jump to, and target. Oh yes, I know why. I understand. So it. Oh god, wait, do I need to say plus or minus? Oh. We are doing the relative offset between target and function. So we say target minus function. That's the offset. But we are not taking into account that this offset is calculated from the next instruction. So plus couple of bytes. Now I understand why I never did go that route. It's so painful. Yeah, it's a good idea to not go that route unless you absolutely have to. It's a very, very painful development process. Hell yeah. Rust is freaking awesome. And I'm very glad Linux is jumping on the train. Because it's just the perfect language for kernel mode developing. Oh yeah, we are 9 bytes off because we are already skipping the few bytes we are writing, which is 5, and then we also need to add or subtract the offset from the relative address. Oh god. Or actually we could just do this before we increase. Forget to build some vectors. Well, it doesn't really help you because I'm not rich, so I don't have an officially signed driver. It's just a test signing, so I mean, if you want to read and write onto the physical memory, you can just make your own driver and then put Windows into test mode. But yeah, that happens sometimes. Funny enough, this is not actually a big deal anymore, or not that much of a big deal, since with virtualizable CPUs, you have second layer address translation, which is virtual memory on top of virtual memory, and kernel drivers and the kernel itself is now running inside virtual memory, which is then managed by, I think, HVCI or something it's called. So basically, the TLDR is when you find a backdoor into a vulnerable driver, you can't just add code, you can't just make sections executable and so on. You actually have data execution prevention inside the kernel, because you're not accessing physical memory inside the kernel anymore. It's pretty cool exploit mitigation. Anyway, where was I? Got into a rant. We are casting to uint32, so uint32. This is the offset between target and function. Jump offset. Oops. And that's what we need to jump to. So we're doing this before we are increasing the target. That opens a lot of other potential, I guess, as always. Every isolation offers its own escalation methods. Yeah, but now you would have to find a bug inside of, well, the module that translates virtual to physical addresses, which, well, you're exploiting virtual memory and the memory management unit on your CPU, which is like a tiny risk and has been way more tested and stuff. Especially way more... One sec. Right. Especially way more tested than just the kernel drivers of random companies like MSI. I'm referencing MSI because there was like a big thing that happened where they published a vulnerable kernel driver that had valid signing. I'm not sure what you're referring to. That sounds interesting. Okay. Sounds very weird. Why am I not getting... output to work via measuring time? Well, yeah, I know how timing attacks work, but I don't understand how that could be applied to virtual memory. Or do you mean side channel attacks on hyper-threaded CPUs? Because I am aware of those. Oh, is the driver still running? Is that what's going on? It is what's going on. Well, that explains a lot. What? I don't give a shit. Here we go. Now we land precisely where we need to land, which is 5 bytes after the target. And I'm gonna stop the driver because I will forget again. And now for my next trick. Cannot give you the full exploit, but I guess not the same is true for every hypervisor anywhere, as there are often some parts of the shell. Run on address space. It's not a complete virtual machine, it's just the second layer address translation part, which is one type 1 hypervisor trick that it uses, but it's not a full-on VM. So, and yeah, of course, there will be exploits inside hypervisors always, as with all software. I mean, we've seen exploits in CPUs themselves, which is insane. It's just about minimizing the attack surface. Alright, next step is writing shellcode that loads our DLL, which should be super easy, and then jump back. Yeah, that's pretty much it. Oh, and of course execute the old shellcode. No, not shellcode, the original instructions. So I'm gonna open hook again, because I have done this for 64-bit, so I can just look at my old code. Solution at present for attack surface reduction is to simply deploy everything as VM. Yeah, true. I have a server around here where I'm hosting all my stuff, like my website and some gaming servers and so on, and I'm just doing everything with Docker, which is pretty secure actually. It's become pretty resistant to VM escapes. I mean, it's not a VM, but you know what I mean. And it's also very simple to add and remove new software, so I just love that kind of setup. Oh, hell yeah. Docker is fucking amazing. Oh, Wasm is also amazing. Love that technology. I don't know about that. I don't think it will replace all the containerization. First, let's do a little data segment. And there we place the name of the address we are loading, and also we are gonna place load library A, which we also need, obviously. Co-founder of Docker believes Wasm can take the place of... I mean, I'm not gonna base my viewpoint on reading the header of what some dude said. I mean, maybe you're right, but I'd have to look into that. It just doesn't sound very convincing. Because no matter what you do, the performance of God, words are hard. The performance of a JavaScript or Wasm virtual machine just is not going to be the same as running native code. And well, Docker runs native code, so unless you make GPUs that can run Wasm, you're just not gonna have the same kind of performance. And for some things you need this performance, and also some things just can't easily translate their code to Wasm instead of, well, normal native code. I mean, sure, most web apps will probably do WASM sooner than later, but what do you mean I'm not correct? What are you trying to say? That WASM runs faster than native code? Because WASM is translated to native code, so by definition that's not going to work. Following tests, we have measured the performance of several web application platforms. Just is the second one. It is wrong. Yeah. I have no idea what you're saying. I may be misunderstanding you, but from what you're writing, I am interpreting it as you telling me that an interpreted language is faster than one that compiles to native code. And that's just not a thing. I mean, yeah, the second fastest framework can totally be a JS framework. I could believe that, it's sure. That just doesn't mean that JS is faster than assembly code, because, well, you do realize that the JS has to be translated into assembly code to run on the GPU, so there will always be an overhead. Well, unless, of course, you have CPUs that can natively understand JavaScript. You ever try to write async ASM? What? No! I also do not write ASM, or anyone that's writing programs. They are writing languages that get compiled into ASM. Just like JS is compiled into ASM. So I mean, technically if you're writing async JS, the compiler is writing async ASM for you. I am language implementer. Alright. I mean, I'm probably misunderstanding you, as you're not making too much sense to me. Anyway, we have the data segment, so next up... Wait, why am I putting my data segment below the code? Makes zero sense. Gonna put it here, and we do need, actually we need to put it, let's do it here, because we need to jump right below it. Jump to the shellcode, and in here first we need to get the PEB, the processor environment block. I wrote a little function that finds an export, but actually I'm not going to use that function. We only need to find one export, so I'm not gonna make that a separate function. Okay. First, we need to push all the registers. Or do we? Yes, we do, because we are in the entry point and the program expects things to be unchanged, so... what is it? We need the calling conventions, specifically the one that Windows is using. Windows API calling convention. It's std call, that's what I suspected. 132 API. Yes, 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 yes. Okay. And we need to know which registers are being modified. So Windows std call convention. Wait, when do I need to go? Okay, I have like an hour or so. Let's go and do argument passing, stack maintenance. Yes, yes. What do you mean write down what I'm searching for? It's not telling me which registers are safe and which aren't. Maybe none are. Because I know that with fast call you have certain registers which will be modified by called functions, and some that won't be. Yeah, if it's not on MSDN, it's probably nowhere. So I'm just gonna assume that it's modifying everything. std call variation, blah blah, parameters on the stack. cdeclare registers are designated for use within the function. EAX, ECX, and EDX are used within the function. Okay, does that mean the others are safe? I'm just gonna assume that Wikipedia is not lying to me. And of course that I'm not misunderstanding. So the first thing we need to do is save those registers, EAX, ECX, and EDX. ECX. Oh, come on. And then pop and reverse order, EDX, pop, ECX, pop, EAX. And then I'm gonna yoink this. And go. So this is the first code we need. Push EAX write bytes function 50. That's the opcode. Wait. Push EAX. That's better. Write bytes function 51. Let me guess, 52? Yes. Whoops. And then for popping them, 5A. Push, no, pop ADX. 9? Well, that's weird. Sure. ADX. No, it's actually not weird because we are going down, not up. So 5.8 is probably going to be the next one. Yes, it is. Pop EAX. Then we don't need this anymore, and this is actually going at the bottom. So in between here we need to write the code. And the first thing the code will do is find load library. And to do that we need a counter first. So we are going to X or EAX, just we see on the left hand side from our earlier code. Not X, used to 64-bit things. Okay, first we XOR the counter, then oh yeah, I'm doing a clever little trick so I don't have to use 2 jumps. Decrease EAX, so we start with -1, and then we can just instantly increment EAX again. I'm doing this so we can jump to this increase over and over again and start with it, so we only use 1 jump instead of 1 up and 1 down. It's just cleaner. I mean, that's debatable. We need to use ESI because we are using the rep e compare single byte instruction. Rep e compare single byte. Rep. Here we go. Oh no, wait, actually I need rep e. So we see rep e compare yeah, I'm assuming we can do our prefix after that. I'm matching bytes in EDI and ESI. Yeah, it's the same as in 64, unsurprisingly. P equals compare single byte. I don't think we need any operators, do we? Nope, we don't. There we go, there's 5 viewers, followers, and primes. Eric Panna Uwu. Great, thank you very much for that insightful message. Now I can actually find out how to ban people on here. Block, prevent from sending, prevent from purchasing, filter out messages out of chats. Well, that's not what I need though. How do I block someone? I mean ban. Can I slash ban? Yes! That's cool. Oh god, I need to copy the name. Where is my autocomplete, huh? Easy. Here we go. Rep equals passing right, and yeah, of course before that we need to do a couple of other things, namely clearing the registers this instruction is using, which is EDI and EDX, I think. There we go. Right, function 33 and CO. So we're using EAX as a counter. And start counter at -1. Yeah, I know I could have written -1 in there from the beginning, but I don't know, that's just a weird instruction to write. Increase counter by 1. But we need to also mark this location. We do that by making a new variable. Next string, this is the label, so to say, equals target. So we mark the current location of the pointer. Wait, what am I doing? This is all wrong. No. I could do this and then do wait, what? Is it? Oh, I wrote percent instead of colon. Here we go. So we replace func by target, because that's where we want to write these bytes. Increase counter by 1, and yes, we need to clear RSI. We do by saying XOR ESI, and then I'm writing the functionality to find the export, but I don't even have a pointer to the export table yet. Yeah, we need to do something else first, and that would be pass the PE header to find the export table, which is what we do here. So first of all, here we go. First of all, I am putting the PB inside EAX. The PB is at the TEB at offset 60, but I have to say hex 60. Oh yeah, forgot a colon. Here we go. For those unfamiliar, what is TEB? No, I want Wikipedia. No. Here we go. Contents of the TIB. Oh, the TIB, of course. That's why I couldn't find it. So the TIB is in a special segment which is called GS, and at offset 60 we find the PEB process environment block. And now that I think of it, we don't actually need offset 60. It's good that I looked it up, because we need 30, because we are in 32-bit mode. And the pointer size is, of course, halved. 30. Here we go. Right, so we got the PEB, and now we need to get the LDR. This is the loader, and it contains links to the base address of loaded DLLs, namely kernel 32, which is what we want. So I'm gonna move into EAX. EAX plus probably not 18. Here we go. 0C. Wait. What? Interesting. Hey, dir auch einen wunderschönen Freitag. So instead we need C. So we have the LDR inside EAX, and now we need to get the in-memory order module list. So here we have the LDR structure. In-memory order module list. So instead of 20 we do 14. Sweet. So then we need to dereference it twice. So we go over NTDLL and straight to kernel 32. So we take the forward link, we can just say offset of list entry forward link. That should be universally applicable on both 42 and 64. Jesus Christ, that's a long macro. Oh yeah, it's just 0. Because it's the first entry always. And we do this twice to get to kernel 32. So now we have the entry for kernel 32, and now we need to get the DLL base address. For that we need to go one step up and then a couple steps down. I'm just gonna write this out real quick and then we can move on. Next step. Right. Target. You know what? I did something completely ridiculous, but it's very useful. I made this little function in JavaScript because I'm a lazy boy. By the way, what? Did Edge just ask me if it wants me to open the DevTools? So now we can do this easy. Oops. Here we go. So here we are. Get PB process and block PB. Next up, we what's next? Getting the LDR. Yes. Oops. Would have probably been faster to write this out. Oh wait, could I? Yes, let's do this a different way. As you can see here, I didn't hard code the offsets. Instead I'm using offset off. Did I define this one myself? I did. So now the question is it compatible? It should be, because this... No. Fuck, it isn't. Ah, that's so annoying. because we are compiling in 64-bit mode. So the void pointer has a size of 8 bytes. But inside the process it's 4 bytes. Wait. I got recommended a GitHub repo that holds undocumented definitions, and if the PEB is in there I can just copy paste it. So this is what I'm talking about. Let's see if we can find the PEB. Yes, we do. Yes, and it has anti-wow as well, and the LDR. And the LDR 32. Only processor dependent. Okay, how about in here? Yes! Jesus Christ. That's an insane definition. Holy shit. Yeah. These are only header files if I'm not mistaken. Yes, they are. That is so wonderful. Because that means I can just git submodule add this into dependencies. Oh, dependencies /phmt. And boom, we have the new dependency. And in the CMake lists, we can now do target include directories, kptm hook public CMake current source dir /phmt. No semicolon. And that appears to be working. So now we can hopefully include phmt. I totally forgot the names. Anti-wow. Sorry, had to go for a moment. What's the music doing? It sounds different. I want this one. These one. Where was I? Here. Okay, instead of doing this, okay, this we still need to do, the PB. But also I could do this prettier by doing right type target and 30, and right type needs to be a fuck, what is it? Let me just cheat and look in my old implementation. uint32. 1, 2, 3, 4 bytes. Yeah, uint32 checks out. And of course it needs to be hexadecimal. And then we get the PEB. Instead of hard coding this C, I'm gonna write type uint8. No, I can just do it in here. Offset of PB32 LDR. What? PB32. Oops. LDR. Okay, autocomplete just did not seem to like me there. And do we need to cast this? Apparently not. Sure, let's go. Okay. Get LDR. Next up is get memory order module list. First entry is main executable. Right weights target and oh wait, I have this up here. 8B and 40. And then offset of PEB LDR data 32. Memory order module list. Is it named that? I don't think so. Oops. In memory order module list. No. Yes. And we have to... No, actually, we don't have to subtract it. That's it. And then just dereference it twice. F-link to next entry ntdlel. Right, target. (8b00). We can be fancy and do 8b and then offset. Oops. Offset of list entry 32 f-link. F-link. Typing is hard sometimes. It's your issue. Oh, of course. Why would I type this? I can just copy it. Kernel 32. And now we have K32, we need the DLL base, and this is a weird one, because we are currently here, and we know the offset of this, but the offset is obviously based off of the first entry, so from 0. But, well, as I said, we are here, so we need to only go one step further. But instead we're going to just subtract current offset, go back to 0, and then go to 18. Because believe it or not, that's easier to do. More obvious, whatever. But I have a hair in my mouth. I need to go in like 10 minutes. But first I want to get the base address. Move EAX x plus 20. This is not gonna be correct. I just need 8b40, which I just realized is the same as this anyway. Base address from LDR list entry. No, I mean, an offset is obviously based from 0, so you have, if you have the offset 14, it is 14 bytes away from 0. But the funny thing is that this linked list, the forward pointer doesn't point us to offset 0, it points us to offset 10. The reason is that it points us to the next forward link, so we can traverse it by just dereferencing the same thing again. So we are essentially here, we are at offset 10 and we need to go to offset 18. So instead of doing the current one plus 8, we go current one minus 10 plus 18. That's what I was trying to explain. Oh, shit, I'm still in the browser. PB LDR data entry? I have no idea what the name is in this thing. LDR data table entry. Hell yeah, that's what I was looking for. And in here we have DLL base. And of course, I don't know, oh yeah, I just guessed the correct name, that's good. And then we go offset off LDR data table entry and the current one where we are. And where we are is... where we are is in... no. In memory order links. Pretty sure. In memory order links. Yes, that's where we are. In memory order links. So essentially what we're doing is, I was talking shit earlier, we are not here, we are here, we are at offset 8. So we subtract 8, so we are now at offset 0, and now we add 18, so we are now at offset 18. Cool. Now we save it, we do some building. Cannot open included file. No such file directory. Did I include it wrong? Let's see. PHNT. Include directories. And in here are the headers directly. Oh, yes, of course. This is what I need to do. Just kind of awkward. Why not just adding the difference? Yeah, it will work fine, you're totally correct. I could actually just write, instead of doing this, just write 8. But you can see how instead of writing raw numbers, I'm writing offset off. The reason I'm doing this is portability. I know that the PB and stuff is not going to change anytime soon, but if it does, this code, given that the definitions stay intact, will be correct. I'm just generally not using raw offsets, not using raw numbers, but using this offset off thing to actually get the offset from the structure definition. And I cannot, I'm not aware of a method to calculate the offset or the distance between two values or something like that. So I'm doing this whole ordeal to subtract them, to essentially find the difference between those two entries. Yeah, so I'm just doing all this because I don't want to hard code the offsets. I want to use the structure definitions and get the offsets from there. And I can give you a rundown on how this code will actually give me the difference. Yes, 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 you totally got that correctly. You understood it. This code here will give me the offset of DLL base, which is 18. And this code will give me the offset of in-memory order links, which is 8. So in reality, we actually are saying 18 minus 8, because I'm doing, well, this one minus this one, 18 minus 8. And that actually gives us the difference we need from here to here. But conceptually, we are essentially going back and then down here. I don't know, it probably was a confusing explanation. I could have just said that we get the difference. Would have probably been easier to explain. Sometimes my brain works in mysterious ways. Okay. I think it expects us to. It expects us to include it directly, I think. Identifier is undefined. Okay. Do I need to include something else? This is the first time I've used this project, so maybe I'm missing something on the usage. Oh, usage. Well, my program is not using the latest Windows SDK. Designed to be used in user mode programs. Well, that's also not what I'm doing. Fuck. What? Top of your program first line provides access to the Windows 32 API. Second to the native API. Oh, okay. Should I just include the main one, maybe? But also, am I supposed to... Oh shit, I actually need to go. Just realized. Yep, I gotta get moving. Hope you have a great rest of your Friday. Probably not going to be back today, but I will definitely be streaming tomorrow. Goodbye. You too.